In this video, I'll show you how I generate sounds and draw colors to the canvas when a mouse event occurs. As I mentioned in an earlier video, for this solution, I used the Pygame package to play sounds, and I imported two modules from the Pygame package. I imported the sound array and the mixer module. The mixer module contains classes for loading sounds and controlling playback, and the sound array module contains functions for converting between NumPy arrays and sound objects. I also imported the NumPy package as NP up here. Now, before I can use the mixer module, I first have to initialize it, and that's what I did in the last line of my init constructor method. Here I called the mixer.init function, and I configured the mixer to use a sample rate of 22,050 Hertz, to use signed 16-bit values for the sample values, and to only use a single channel, so it'll just be a mono sound. Now, let's look at what happens when the user presses their mouse and the mouse down event occurs. When the user presses their mouse and the mouse down method is called, the first thing it'll do is it'll store that event information, which is passed in using the event variable, to the class variable called previous. And we'll need this value later if the mouse is moved to draw a line from the current location of the mouse to that future location. I also configure the sound on flag to be true, letting the program know that the mouse is currently pressed down. And then after that, we're going to actually calculate and generate that sound array to play. And there's a series of different nested functions here which get called. The innermost one here is called calculate frequency because we need to know what pitch that sound needs to be. And since pitch varies based on the vertical position of the mouse on the screen, I index out the Y value from that mouse event and I pass it to my helper function here called calcfreq. So let's look at calcfreq real quick. This first line of the calc method uses some basic math to map the vertical Y value of the mouse to a number between 1 and 88. As the mouse moves towards the top of the screen, it gets closer to 88, and it moves down towards the bottom of the screen, it gets closer to 1. And the reason I'm mapping it between 1 and 88 is because that represents the 88 keys that are on a standard piano. I then take that value for the piano key that the mouse location corresponds to, and I use a little math here in this second line to map that to an actual frequency. I do this by relating that key location to the 440 Hertz key, which is the A located at key number 49. And through this equation, we can calculate the frequency that should be played based on the Y location of the mouse. The calc method then returns that frequency back to the call here in the mouse down method, and that frequency is then passed to the sine wave helper method. As the name of the sine wave method suggests, it takes in a frequency and it'll return or generate and return an array of samples representing a sine wave of that frequency. Since this sine wave sample is going to be looped repeatedly, we want to represent it as a single period of the waveform so that it'll loop smoothly and we won't have little clips between sequences of samples. To do that, I calculate the number of samples we'll need for our waveform by dividing the sample rate by the desired frequency, and then using that number of samples, I pass it into the NumPy aRange function. This will return a range of numbers from 0 up to that number of samples minus 1. And I pass that over here to the NumPy sine function, which will take that range of samples and return an array of the sine of each element from that range. So I take that array representing the sine values, I multiply it by 2π, divide by the number of samples, and ultimately scale it up by 32,000 so that that value will extend to the maximum range of a signed 16-bit integer. This gives me my array of values, and finally I use the asType function here to convert it into a 16-bit sine value, which is what I return from the sine wave helper method. That array of sine wave samples is finally passed over to the makeSound method from the sound array module, and that returns a sound object which I store here to the sound variable. Now that we've generated our sound to play, we'll need to configure the mixer to actually play it at a certain volume. And we can do that by calling the setVolume method on that sound object. And to calculate the volume, I use this other helper method I created called calcVolume. And since volume is changed dependent on where the X position or the horizontal position of the mouse is, I index out the X value from that mouse event object. Now the calcVolume method is pretty straightforward. I simply divide that X position by the total canvas width, and this will give me a volume value somewhere between 0 and 1. So I pass that method to the setVolume method up here, and then ultimately I call sound.play, with a -1 input parameter, and that tells that sound to loop indefinitely. So that's what happens when the user clicks their mouse and the mouse down event occurs to actually start playing a sound. Now let's look at what happens when the user moves their mouse. That'll trigger the mouse move event. And as you can see at the beginning of the mouse move event, we first check to see, is the sound playing? Meaning, is the user pressing their mouse down? If so, we'll need to create a new sound array for the new pitch based on the current location of the mouse. We can do that using the same calls we just saw in the mouse down method. And I store that new sound to a local variable here called new sound. Using that new sound object, I set the volume exactly like we just saw, and I also use play -1 to start that sound playing indefinitely as well. Now to stop the previous sound, I take the sound object that we were previously playing and I call the stop method on it. And then I store that new sound to our sound variable. I created this overlap to try to prevent a little glitchy dead space from occurring between the sounds as they're switched. In the end, I don't think it actually makes a difference, but I left a little switcheroo in there anyways. After we've started playing a new sound if necessary, the next thing we need to do, and which we'll always need to do if the user moves their mouse, is change the background color. So we need to calculate new red and blue values for the background color, and I do that using a little bit of math here to convert the X and Y locations to R and B values between 0 and 255. Those will both be integer values as well. The math here is designed so that when the mouse is moved towards the top right side, or towards the top of the screen, the R value will be stronger, and it's when it moves towards the bottom right side of the screen, the blue value will be stronger. I then take these calculated red and blue values, and I use a little string format here to create a hex string. It'll be a hex value with those red values, the static value of 50 for the green values in the hex code, and then the two blue values. I use this value of 50 here, or hex 50, because I felt that adding a little bit of green to the color palette gave some pizzazz to the program. And after configuring the background color, the last thing I do is I check to see if the mouse is down and there was a line being drawn. I do that by checking to see if we have a previous mouse location. If we do, then I use that previous mouse location and the current mouse location from the current event to draw a line between those 2 points. And I color that line in using those same R and B values that we just calculated. I just use a different center green value here so that it's a little bit brighter. And after drawing that line from the previous location to the new current location, I then store the current event location into that previous variable so that the next time the mouse is moved, we'll be able to use that location to draw a line to the future spot. Now, the last method for us to look at is the mouse up method, which gets called when the user releases the mouse button. It's a pretty straightforward method. I just set that previous event to be none so that we know that the mouse is up and we don't have any more lines to draw. I use the canvas delete all call here to erase everything off of the canvas. And unfortunately, that also erases the text message at the bottom of the canvas telling the user to press escape to quit. So I use this line here to redraw that text message. I then set my sound on flag to false so that I know the user is not pressing down the button. And I use the sound.stop call to end the sound playback. And that's pretty much how the Theremin program works. And for a program that's just over 80 lines long, there's a lot going on here to generate sounds and to manage the canvas. If you want to learn more about using the Pygame package, then I recommend looking at their website, pygame.org. The packages are well documented and they have a lot of example projects that you can look at too. And if you want to learn about using tk-enter to build a custom user interface for your Python programs, then I recommend checking out the lynda.com course on Python GUI development with tk-enter.